You also missed one of the review days. Although you didn't, Seth, although you didn't miss both review days, you did miss one of those, so maybe you just weren't in the right frame of mind.
No, I really wasn't. All day yesterday was not a good day or quiz day.
So let's make this up. All right. Hey, okay. Actually, all right. Wes, you got 91?
Yeah, but I got like the decimal thing wrong.
Did you get them wrong, or you just did
I
them wrong?
put the decimal. I didn't round it.
All right. Well,
Yeah.
so that was your tax on not following instructions, but you still got an A.
Oh my gosh.
No.
You got 91. I got 93. I'll tell you what you got.
Mike, you got the highest score. All right. Here's the warning. Hey, this is the easiest class of the year. There's no proofs. Chris is not even listening. There's no proofs. There's no calculations. There's no techniques, strategies, procedures. There's nothing. Today is only about definitions. All right. Although I handed you a sheet because you need to look at some things, do some practice one, I want every definition in your book of truth. All right. Some of them you already are familiar with, but most of them you are not. Okay. We haven't talked about circles yet. Today we talk about, or this chapter is all about circles. Why are you not clicking? So this chapter is, it's still not clicking. Go ahead. All right, there's your homework. Oh, now it's clicking. 1 through 11 all, so it can't be that hard. No, today's just definitions. There's nothing, no skills, techniques, proofs, calculations, nothing. Just definitions.
What's the homework?
Definitions. They're going to show you a shape, and they're going to show you a part of the shape. They're going to say, what's the name of that shape? All the things are going to come from the definitions. And as you look at the sheet that I handed out, you can probably already tell what many of the words are. A couple of them are absolute straight up review. You saw them all in K through 8th grade. But there's plenty of new words today. Plenty of new words. This is the only section that's nothing but definitions. All the other ones will have either a proof or a calculation or a formula. This section is just nothing but a definition. All right, basic terms. There are basic terms involving circles. All right, easy day, but boy, are there lots of definitions. Lots and lots and lots and lots of definitions. Okay, vocabulary day. Every vocabulary word goes in your book of truth. Every vocabulary word goes in your book of truth. Okay, just vocabulary, you know some of it. Here we go. If I take a point, you see the point? And I put that point somewhere on the page. Let's put it right there. And I take a measuring device, and from this, I measure a certain distance, right? And let's just say it's 20 centimeters, right? And I put a dot right there. And then I measure 20 centimeters to the other side and put a dot. And then I measure 20 centimeters to the top, to the bottom, to the top, to the side. And then I do this thing not 10 more times, but guess what we make? So what is the definition of a circle?
Round.
It has nothing to do with being round. What's the definition of a circle? That are, what did I just do?
That are equal distance from.
Say it again.
That are equal distance from.
That's the definition of a circle. Circle has nothing to do with being round. I'm not saying a circle is round. I'm just saying the definition of a circle says nothing about being round. All it says is what I just did with the ruler. You set a point, we're going to call that point the center, and you measure a distance. And then you measure the same distance. You do that an infinite amount of time. So a circle is the collection of points that are all the same distance away from a center point. We got to have one extra step, right? Isn't there a point that's also 20 centimeters in this direction? We don't want this point. That doesn't make a circle. So what are we going to restrict all our points to?
One plane.
To one plane. All right, put that with her definition, and we have the first definition in your book of truth. It's a set of all points in a plane, the same distance from a given point on that plane. The set of all points in a plane, that's a flat surface, the same distance. All these points are 20 centimeters away from that center point. And that point also has to be on this plane too. That's a circle. All right, now I'm gonna, if you had me for pre-algebra, you heard this definition before. But for those of you who didn't have me or don't remember it, guess what the circle is not?
Straight.
Turns out it's not straight, sure. Guess what the circle is not? And this is why your kindergarten teacher was wrong. Am I touching, e-learners, I'm touching the middle. Am I touching the circle?
No.
Am I touching the circle? Am I touching the circle? So what's the circle? It's just the points that make up the circle. The center or any point inside of it is not the circle. If you include those points, do you know the geometric shape, what it's called? Nope. The sphere would be points, right? That would be called a disk. So if we include this part, I'm pointing to the center part, e-learners, that would be a disk. But if we talk about the circle, it's just that curved black, we can't say line anymore, it's not a line, it's curved. But that would be the collection of all the points that are, in this case, 20 centimeters away from the center. So even though I just drew my circle as blue, guess what? That blue isn't the circle. The circle is the black curve. Yeah, we like to make our circles shaded on the inside, but the inside is not the circle. The circle is the outside, just the outside. You want to talk about the whole darn thing? That's the disk. And we don't even talk about disk in this year at all. Okay, 1B, in your book of truth, draw that, please. We will label the parts of a circle. Well, first off, we got to name it.
Jeffrey.
Okay, so here's Jeffrey. Now, mathematicians wouldn't call this Jeffrey. Mathematicians would call this
A.
We would call this A. So all circles are named by the point that was used to create them, the center. The paradox is the center isn't part of the circle. Okay, so A isn't part of the circle, yet paradoxically, that's how we name it. Remember, the circle is just the black curve. We have a symbol for circle. Anybody know? Okay. Circle with a dot. That's the astronomical symbol for, anybody know?
Awesome.
Sun. You guys know the astronomical, not astrological, but astronomical. That's the sun. This is Venus. This is
Neptune.
Mars.
Mars?
Yeah.
What? All right, hold on, pick another one. I'm going to guess right this time.
Yeah.
I have to write this one too.
Anyway. You take astronomy next year, you learn it. All right.
Wait, does it mean astronomy?
Mhm.
Okay.
All right, we good on the names of circles, right? And what a circle is. All right, moving on. If I put 2 points on the circle, okay, here comes problem number 1. When geometers actually do this, you see the dots that I just put? They never put the actual dots there, the points, okay? But they'll play connect the points, the shape that connects any 2 points on a circle. Remember, the circle is not the yellow, it's not the center, it's the black curve. If I connect any 2 points on a circle, I made what's called a, anybody remember from 8th grade?
Chord.
You make what's called a chord. So there's definition number 2. Definition number 2 is a segment. Hey, be careful. Not a ray, not a line. It's got to be a segment. You'll see why here in a couple definitions from now. Got to be a segment. Can't be a ray, can't be a line. A segment whose endpoints are on the circle. On the circle is important. If you put a dot somewhere in the center, you're not on the circle. The circle is the black curve. That's called a chord, C-H-O-R-D. So this is circle Z with chord. Well, we got to give the points some names. They just don't have names. I drew them with these big black circles right here. Tonight for homework, none of those will be there. They'll just be a chord. Right? There'll be a letter, but there will not be a little dot. So I'll have some students say, well, I didn't see a dot there. There's not a point. Don't ask me why. I truly don't know why we don't put dots there to indicate the points. Because it makes sense to me, but you'll never see a geometry book that does that. This is what it will look like tonight for homework, right? Notice they'll have letters, but there's no dot there for point G. Point G exists. It's that point where these two, this chord right here and the actual circle intersect. So that's point G. So tonight for homework, what will it look like? Well, they're going to take the definition and they're going to say name something. So in other words, this is circle X. So maybe they'll give you the shape and they'll say, what's the name of the circle? And you write circle X. You can either use it with words or the symbol. They'll say, name all the chords that you see. So let's see, a chord connects 2 points on the circle. So I see chord AC. Chord AC is the same as CA, that's the same chord. And I also see chord FG. You see that?
What about E?
E, remember, it's got to connect 2 points on the circle. So EX or XE is not a chord. It is something else. We'll write it down here in a second, but that's not a chord. All right, we good on name of circles and names of chords. Pretty simple stuff, right? I told you today's easy, just vocabulary. All right, so here we go, Ethan. What's the name of the circle?
Circle X,
Give me a chord.
DB,
And
BD.
that's the same one.
Oh, well, AB.
Okay, so we got chord AB and chord DB. Now remember, AB can be written BA and DB can be written BD. So there's 2 chords there. Pretty easy, yes? Okay. New vocabulary, next one. If you have a chord that goes through the center, we give it a special name. Anybody? That is going to be called the diameter. Di, to meter, measure. Your 2 measures. So if you think about the distance between this point and Z, that would have to be the same distance between Z and this point. So you got 2 of them diameter, right? All right, diameter is how we pronounce it though. So a diameter is a chord that passes through the center. There's plenty of chords that don't pass through the center, but if the chord passes through the center, we can either call it a chord, most likely we use the word diameter. But a diameter is a chord. All diameters are chords, but, finish the sentence. All diameters are chords, but not all chords are diameters. You can have a chord that connects 2 points that does not go through the center. Okay, what's the diameter here? LK or KL is the diameter. So in circle M, the diameter is LK or KL. Now notice I will be a stickler about, well, it is a segment, so you need the segment symbol. You just say LK, you don't have the segment symbol off. Come test day, I'll take a point off for that. So far, this was what you did. You probably had this in 6th grade, and 7th grade, and 8th grade, chords and diameters. The other word that you had in 6th and 7th and 8th grade was, that dealt with circles, radii, radius. Okay. Yeah, dB, done. All right, so the next vocabulary word, if you connect the center to any point, and notice what I said, center to any point. I didn't say any point to the center. I said center to any point. You make what's called a radius. Okay. A radius is a segment that has one endpoint on the circle, and the other one is the center. This is probably the one rule I don't necessarily agree with. They say you must write all radii, plural, for radius. you must write all radii starting with the center. So all radii start with the center. I don't know the root for radius. A radius is half of a diameter. I should know that though.
Through the internet.
Yeah, I left my phone at home too. I usually ask Siri. And she goes, I found this on the web. I'm like, no, Siri, I want the answer. What's the answer? All right, anyone ever not heard of a radius? Okay, good. So we got name of a circle, we got chord, we got diameter. Diameter is a chord that goes to the center. And now we have radius. Now we're caught up with our previous knowledge. Matt, name all the radii in that picture. Say again.
GE,
GE,
and
GE,
GD,
and
GD.
you got them all. All right. Yes, it starts with the center, not with the point that's on the circle. Everybody comfortable now with the fact they won't put circle or little dots next to the points that are on the circle? Okay. All right. Anybody else want to play this game, or we got this? You got this? All right. Moving on. All right. Now the vocabulary, we go into the land of I don't know what these words mean. So these are all going to be your new ones. All right. And there's lots of them, and they won't stop. There will be more tomorrow as well. Okay. Okay. Hey, I got 2 points on the circle, yes? If I connect them with a segment, what did I just make?
Or
What if I connect them with a line? All right. If you connect 2 points with either a ray or a line, now our book only says line, right? But basically what we're saying is we have a shape that goes not just on the circle, but through the circle. We call that a secant. Okay, that's not a hard one. Nor is it hard to remember. Secant. It's a line that contains the chord of a circle. Well, I could have given you a better definition of that, but that's the one they want to go with. A line that goes through 2 points on a circle, right? That would be my definition. But they decide to say that it's a line that contains a chord of a circle. Could go through the center too, because remember, chords can go through the center. That's a secant.
but what if it's, you not call it also the diameter then?
Well, just say, yeah, the chord would be called the diameter, but the secant is the one that contains that chord. So, okay. Secant comes from Latin. I don't speak Latin. So, secare. Anybody help me? Is that right?
Sounds right.
All right. Don't assume that I got that right. Mr. Latin in the back says I got it right. And it means to cut. I'm trying to think of a Latin, an English word that would use secare for cut.
Sever.
Sever, but not a V, right? Okay. So where's my secants there? What do you got, Wes?
AC,
And
DB.
you got them. So my secants are AC or CA and DB or BD. Okay. When's it going to get hard? It's not going to get hard today. It's easy, right? It's just vocabulary words today. Secant, very memorable? No, right? I don't know why, but you'll probably forget this by senior year, and then you'll encounter it in calculus or pre-calculus, and you'll be reminded. I remember back in geometry, we talked about secants. You're like, I forget what that one was. Secant. All right, Matt, give me the secants or secant. AB, that's it. Done. All right, next, new word. All right. If instead of it being a secant, I still got a line, and it can be a ray, and this one also could be a segment. But this one doesn't go through the circle. It only touches it in one spot, right? It only touches the circle in one spot. So the only place that this red line right here touches the circle is at point D. We call this one a tangent line. You're like, wait a minute, didn't I just use tangent and triangles? Yes, and it's the same word. Different meaning this time. It's not a ratio. Yeah, I don't like this at all. Right? Why couldn't they come up with a better word? It's a line, segment, or ray in a plane with the circle that touches the circle at one point. Boy, do you use this a lot in math. It's impossible for you to understand why at this point, but we will use tangent both in trig ratios and in this particular definition a whole ton, especially when we get to calculus, tangents.
Yeah. Those are really good in physics and calculating wheel movement and
So maybe you've heard this, I don't have the demonstration thing. You know, I got a string, right? A rope. And on the end of it, I got a 5-pound ball, right? If I swing that in a circle and I let go, guess what happens? It flies away in a tangent, right? If this is I'm staying right here, I'm swinging around. When you let go of it, it doesn't go in that direction, it goes in that direction. Or if I'm swinging the other way, it goes in that direction. So if I'm swinging around and at this point I release it, it goes in that direction, it goes in a tangent.
It won't go that straight though.
Oh, no. Oh, that's, well, gravity will take effect and curve. I'm saying if there were no gravity in outer space, right, it would go in a straight line.
oh yeah, no, I've watched videos.
Well, there's always gravity in space, so you are, well, okay, but it would be as close to a straight line as possible. This is how we get to planets as we do this calculation. All right, Latin, Mr. Latin. Tangere, to touch.
Yes.
Okay.
I like that.
All right, next word. Now you will see this as well too. The point of tangency is what you would expect. The point of tangency is where the two come together. So if you're talking about the circle and you're talking about the line that's a tangent to the circle, where they touch is called the point of tangency. All right, that's pretty easy. The only reason this chapter becomes slightly overwhelming is because the vocabulary never stops and continues. So lucky for you, you can put all this in your book of truth and you shouldn't be confused by it because you can always flip through your pages and say, oh, what was the point of tangency? Oh, okay, that's right, that's easy. Okay, overwhelming yet? It will be by the end of class. They just don't stop. Like, call it quits. That's enough for me. Nope, more words. Where's the tangent point here? The point of tangency, Ethan? B, easy. So we got tangent line L, right? Circle G, and the point of tangency is B. Nothing challenging about it. Anybody doing their Chandler homework?
Huh?
You doing your homework?
Yeah.
Yeah, just like this, right? Just asking you to name things, correct?
No.
No, what are they asking you to do?
Draw things.
So they're not asking you to necessarily name it, they're asking you to draw a circle with tangent line L at point of tangency B. Okay, so you got to do a little bit of drawing. In order to do the drawing, you got to understand the vocabulary. Is that correct? Yeah. Okay, cool. So name all the tangents. What do you see, Matt?
There's line, and C.
Okay, so line EF, tangent, point of tangency is C. All right. Remember, the tangent line can be a line, it can be a ray, it can also be a segment. So segment EF, but I ran out of space for that as well too. Okay, what's a sphere? What's a sphere?
3D circle.
Say again?
3D circle.
3D circle? I mean, I don't understand why you would say that, but what does that even mean?
Circle at
You're putting
3D.
points everywhere.
Closer to the definition now. How do we draw a circle? How did
The
we?
center?
We did a center and then what?
Added points.
Points.
So how do you make a sphere?
You add
And
points.
You just use all the planes and put points.
We don't consider all the points on the plane. We consider all points that are the same distance away from the center. Okay, now we've come to a paradox. How do you draw a sphere on a flat surface?
You know,
Like this.
So how do you do it?
You draw like a little ring inside, like this.
So what's step number one?
The solid
Draw,
line.
draw your circle.
Okay, step two,
Draw a circle, but it's like facing
it's a
up.
squish circle, right? So like that, and then one extra step, you,
The farthest
the part that you would not see, that would be this part, you make, so it's gonna look like that. Tonight for homework, that's what you're gonna see. In your book, tonight for homework, when they ask you to draw a sphere, this is how you draw your sphere.
Why are they off that, wait, one piece of paper?
I knew somebody would whine about that.
Uh,
Bite me. I did my best. But yes, you were correct. I hate you, man. All right. How do we name spheres?
For points,
By what?
for points.
So it will be named just like circles. So it will be the point that you use to create it. That's how you're going to name it. So write this down, Book of Truth. The collection of points. So it's not on a plane. Collection of points that are equal distance from a given point. That's how you name, or that's the definition of a sphere. I never figured you for someone that would put that much effort into it.
Nothing else to
Okay.
do. They-
All right, we good with the definition? Connor?
You're actually using it.
Yes, he is.
I've just been free
All right.
falling.
Quick notes. That's what I would have done too. All the terms that we use for circles also apply for spheres. Matt, give me a term that we apply to a circle.
Tangent,
So there's a tangent to a sphere. Give me another one.
radius,
There's a radius to a sphere. Give me another one.
center, the diameter.
There's a diameter of a sphere. All those words, we just got to draw them. Well, technically not in 3D because we're doing it on a flat surface. And that's why he has his compass in his hand, because he's drawing these things. It's going to ask you to draw this. So here's my sphere. How would I draw the diameter? That was our first one. Well, what would I need in order to draw the diameter? I need a point in the middle. And then instead of connecting 2 points on the circle through the middle, I'm connecting 2 points on the sphere. Now I drew one of an infinite number of diameters, right? But that would be the diameter of that sphere. I mean, I could have gone from the top through there to the bottom. What was the next word? No, after diameter.
Radius.
Radius. So where would the radius go? So here's the only, I mean, this is an issue of drawing. It's not an issue of what actually happens in real life. Where is the edge? If I want to touch right here, am I touching the sphere? You kind of imagine that the surface is right here of the sphere. So I could draw a point from here to there, and technically that is a radii. That's really confusing for a lot of people, because how do I know that that point is on the circle? So in order to get rid of confusion, most of the time that you see a radii drawn on a circle, not all the time, but most of the time, they will always draw it to the squished circle, because that's going to be very clear that there's a point right here. So now your radii, I'm not saying you have to do that. I could have drawn, from this point right here to the center and claim that that's a radii, but doesn't that look weird?
You missed the line.
Yeah, but I'm saying this point right here, we'll call it A, is on the sphere.
I'm talking about your line. I see the word radius. What's your line?
You don't see the blue? You're colorblind. You're just bad as me.
Oh, I can't see.
Okay. We good? What were the other words?
Secant.
Secant. What's the definition of a secant?
Where the line just goes all the way through.
So what would I need on a sphere for that to happen? I would first need,
Line segment.
2 points.
I need 2 points on the sphere. So there's my 2 points on the sphere. I'm just claiming those are on the sphere. Then what do I need?
Where the line that goes through.
Okay. Now here's the issue, and it becomes a visual thing. If that's the sphere, here's the line that's impacting it. To go between the 2 points, though, you wouldn't be able to see it.
We're gonna have to go it all
So they're going to draw it. They're going to put a dotted line. That means that if I'm going through the center of the circle to the other point, you're like, well, doesn't the other point have to be dotted? Yeah, that's kind of weak, right? They don't do that. Would you be able to physically see as it came out of that point right here? You learners are pointing to the point on the right. Would you be able to physically see that?
Nope.
Or would it be behind the sphere? So it's got to continue to be dotted to right there, but then magically,
The other side.
the other side you can see. So that's how they will draw a secant. Secant. Yeah.
On your first line or ray, the end is not dotted. It's
'Cause that's
supposed to be
just-
dotted.
Yeah, because this is the one you would see. Imagine this is a basketball. Here's the line. Would you see this?
Oh, yeah.
What you wouldn't see is as it went through the basketball, but on the other end it would appear, and that's why this one's solid. So when you see this, this is what a secant will look like on how you have to draw it as well too. Okay.
Perspective is wrong. The arrow should be bigger if it's closer to.
Oh yeah. So you do better than I did when you draw yours.
And you should see the line of the arrow in front of the line of the circle.
Oh my gosh, do you want us to put?
Oh no,
shades
I
to-
got that part right.
Yes.
I agree with it. I could also do better job on shading or something as well too.
Yeah,
But I agree on the size. You're correct on that. All right. What's the last one I've left off? Tangent. So a tangent is a line segment array that. So here's my line segment array. If I touch that sphere, will I see the tangent line? I will always see the tangent line. So you will draw a tangent line like that.
That is not a tangent line.
Sure it is. Imagine that being a basketball, and I place this ruler on top of the basketball. You would see the ruler. Now you might argue, but what if the point was on the back side of the basketball? Okay, so I'm not claiming that point's on the back side. I'm claiming that point's on the front side. If that point's on the back side, then between these curved lines, that would be dotted or dashed. And then your brain starts hurting, right? There's my tangent. We okay? I told you today's nothing but vocabulary. And we're not done yet. We've got plenty more. We okay on all that stuff? Okay. So name a piece part and give me the name. Go. Pick a piece part and tell me the name. What?
Tangent AT.
Tangent AT. Bree, pick a piece part, give me a name. He picked AT. He said that's a tangent.
You sure? It's shy. It just touches one point.
You can pick any part up there. Now you pick the part and we'll help you. CB is a secant. Okay. Notice we wouldn't see the inside, but it goes through the circle. All right, Chris, what's the only? Oh, we left off two pieces. What haven't we named?
Radius AO.
Radius OA. Wes, last piece? Diameter DB. All right, we got all the pieces parts. We left off circle O. And remember, radius, there's lots of them up there. We need one of them, right? But there's more than one. There's a chord, right? CB is also a chord. But yeah, we mostly considered CB a secant. And tangent AT, we got them. It's no. We're not making it stop. Let's pile on some more. All right, here we go. Congruent circles. If two circles are exactly the same, it's the easiest thing to prove. You just need to prove that their radii are exactly the same. If you have two circles where the radii are congruent, then they have to be congruent, the two circles. By the way, in parentheses, it says spheres, so this also applies to spheres. Hey, in triangles, we got to do a whole bunch of stuff. SAS, AAS, hypotenuse, leg. On circles or spheres, we just need to show that one little tiny piece is congruent, just the radius or the radii of both. So though we will call them congruent if their radii are congruent. Sounds simple enough. It is. Congruent circles or spheres.
But wait, is there any other way to find congruency between two circles?
You're going to show that the radii are congruent. You could say if their areas are congruent as well too. If their circumferences are the same as well too. But an easier way of doing that, and so instead of saying pi r squared or 2 pi r, just show r is the same. So I don't need to go through all that hassle. If you're given that you have two circles with equal area or circumference, then yeah, because you conclude, then therefore R's have to be the same. All right, so if AB is congruent to CD, then those two circles are congruent, and the same thing applies to spheres. Next one. All right, now you may or may not have ever heard this word before. It's called concentric. Concentric circles. These are going to be circles. They must be in the same plane, so flat surface. And all the circles have the same center. Can you visualize that in your head? What that would look like? What would it look like? It would look like an archery target, right? So it would look like something like, well, maybe that's not an archery target, but yeah, kind of sort of like an archery target. Wait, my archery target has deer on it. All right, well, we're talking about that kind. I had a kid say that once. Those are concentric circles. If we have concentric circles, we would have also concentric spheres. Next one. What would this look like?
I don't even know.
Terrible.
You've seen this before in science class.
It's just a jawbreaker. It's just a
Jawbreaker?
Jawbreaker.
Or you see it in science class all the time, 7th and 8th grade. The Earth, right?
Alright.
Core, mantle, all right, let's see. Crust, mantle, outer core, inner core. Did I get that right?
Yeah.
I think so. It would look like that thing.
Yay.
A jawbreaker, I like that one better.
That looks terrifying.
Kind of like a Russian doll, but
Yeah, exactly. Exactly.
Why do we like with the humans in this weird fascination?
Of?
Things and things and things and things.
What?
Putting things inside of things inside of things inside of things. Like you put a box inside of a box inside of a box sometimes.
Well, for presents, you like put like an iPhone in a little tiny box, and you keep
And force them to
getting
keep
bigger.
opening it.
Yeah.
And then they start shaking it and they throw it against the wall.
Yeah.
Break the phone.
All right, concentric circles, concentric spheres, nothing hard about that unless they ask you to draw one for homework.
Oh god. Please
no.
They're not going to give you a concentric sphere.
Oh.
I
right?
was gonna say like how is it?
Yeah, that would be a tough one to draw. But concentric circle, and we will do plenty of geometry with concentric circles. All right, so those are technically all the easy ones. Now comes the ones that you're not going to remember, and they're hard. All right, you ready? Here we go. First one is called, and there's only 2 left, so we're almost done here. First one's called inscribed. Inscribed. I could not remember these when I had this in high school geometry. Eventually, I don't know, maybe it was repetition of hearing the word over and over again. It finally stuck with me. But this one never stuck with me. Inscribed. That's when a shape on a plane fits. Oh, that's not a very math definition. Fits snugly inside another. That's kind of weak definition there.
Yeah.
So I'm going to show you the picture of an inscribed or a circle inscribed inside of a square. Here's a circle inscribed inside of a square. And this is what it means by snugly. There's no loose parts, like one side doesn't touch the other side. Right? All 4 sides of the square are touched by the circle. This is an inscribed square.
But wait, wouldn't snugly kind of be like if you're snuggled up against something, you're like right up against it?
It would be, but you couldn't squeeze that side of the circle against
But
the
look at
square.
the four-
Otherwise, you'd have 2 squares, right?
The 4 sides of the circle.
Yeah.
That are touching.
If there's a weak definition in geometry, here you go. I wouldn't want to try to prove that definition because I'm not sure I could. What?
Can you prove this?
Yeah, this is the one that luckily is a definition. You don't have to prove definitions. I got to
You
prove
said I would
theorems.
ask you to
But,
prove
yeah.
anything.
No, no,
Can
no.
you prove this?
I got to prove any theorem. Any theorem that I say, I can call, if I want to call you Fred, by my definition, you are now Fred.
Okay.
Definitions are, you can say anything for a definition.
And corollaries?
What would the opposite of this look like? Like if we flipped them around.
A square inside a circle.
Could you do that?
Yes.
What would that look like?
Ugly.
Weird.
It'll look cool.
It would look like that. No, I didn't draw a square. I put a
rectangle.
rectangle.
I want to see a square.
I want to see a square too.
You can draw it by yourself.
Square. You have to
You
draw
think
a
we
bunch
can
of
do
them
that?
anyways.
Obviously not,
And
so you can't really
Chandler
make
just said you're going to have some of these tonight for homework.
Thanks, Chandler.
Yeah, you
All
can
right.
draw a circle.
So if this is a circle inscribed in, okay, it doesn't, fall off the tongue very easily. A circle inscribed in a square. What's the name of this one?
A
Square
rectangle
inscribed in a
inscribed.
circle.
That's a
Good
rectangle.
risking.
All right. That's inscribed. A pro tip for me, and this is what I didn't realize until later, inscribed has the word in it. So when you talk about what's being inscribed, you don't look at the outside, you look at the inside. Hey, what's on the inside? This is an inscribed triangle, inscribed quadrilateral, inscribed pentagon. Okay? So the thing on the inside is what's being inscribed. Okay. And you can have inscribed circles as well too. I just showed you one. Okay, what's the opposite of inscribing? The next word.
D's.
All right.
Outspreading.
All right, here we go. Write this one down. Here is circles. I did have one. Okay, so the opposite of all this, and our last word for the day finally, is circumscribed. Okay, circumscribed is exactly the same picture, but instead of talking about what's on the inside, you're talking about what's on the outside. So it's literally the same picture, but this is a circumscribed square. This is a circumscribed circle. The square circumscribes the circle. The circle circumscribes, that's a rectangle, not a square. Now you can make a square just by adjusting the sides. And I should change that. I shouldn't say square because that's a rectangle. All I have to do is shorten this side, like move it in this direction, and eventually I'll get a square. Inscribe the shape on the inside, circumscribe the shape on the outside. And that's it. With 3 minutes to go. Some years I don't make it through the end of this one, but because there's just a whole bunch of vocabulary words. All right, Chandler, give me a question that was on the homework. Off the top of your head.
Draw a circle and a triangle.
Draw a circle inside of a triangle. Okay. You draw a triangle, you put a circle inside of it.
And then something about drawing a tangent.
You got to draw a tangent to a.
It's number one. Oh no, number two.
Draw a circle with center O and line TS, tangent to circle O at T.
Okay. So all you got to do is read carefully, read closely, and it's no big deal. Yes? All right. That's it. So once again, circumscribe talks about the thing on the outside. So this is a triangle that circumscribes a circle. This is a square that circumscribes a circle, blah, 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 blah. Or if I want to put the circle on the outside, these are a circle that circumscribes, here's your square, rectangle, trapezoid, and quadrilateral. Pretty simple stuff. That was it. This was classroom exercise. We're not gonna do that, but that's it. And if Chandler did this in 20 minutes, you guys should be able to do it in 20 minutes as well. Complete, Fertig. End or finished. What's finished in Spanish? You guys are taking Spanish. Finite? I don't know. Fin?
I thought it was termino.
Oh, yeah, yeah.
If you say like termino, like
Termino?
yeah,
Finished.
termino.
What's Latin? Finished in Latin?
Sin. That's what
That's without. Yeah.
I'm not Latin qualified.
All right, e-learners, any question? I don't know anyone else online right here. If you have any questions, send me a chat or an email, and I will catch you guys tomorrow.